Thanks, Denise, for the great introduction. You make me sound very impressive. Thank you, everyone, for joining us today. Today, we are going to give you a brief history of what we had, the next steps we took, and the new solution. And finally, some future options with the Downtime app. After that, we have a brief demonstration of the app and its uses, before I pass it back to 32Soft for some information on their part. Dynacast wanted to improve track machine status at various operations in the manufacturing process to improve OEE and operational excellence. We have 56 casting machines and several secondary operation machines and processes. Tracking downtime or uptime was manually processed, and data was not very easy to review or analyze. Additionally, production quantities was only captured at the scale counts and a downstream operation, and then backflushed into QAD. The major issue with data capture at the casting machine is that most of the machines do not have network accessible computers or PLCs, so they cannot communicate their status to QAD. Management wanted to start improving OEE, and any data capture had always been manual. Machine status data was difficult to review and analyze. The only real visibility into production quantities were from the backflush. There was difficulty in understanding how the machines were running. The difference between the running machines, actual counts, and good shots versus the scale counts, good parts. To capture machine down and uptime, we used a production timesheet, like this one displayed. Machine operators recorded data for each date, machine, downtime code, and length of time by marking the respective down code in the appropriate box. This is an example of a shift one part of the downtime sheet, and it was similar for the pieces below for each of the other shifts. This slide is an example of some of the downtime codes entered on the production timesheet. So the manual production timesheets, the data was collected daily. The data was entered into a spreadsheet weekly. We have, as I said, we have 56 machines times 3 shifts times 5 days, and that's a lot of pieces of paper. This was very time consuming and took about 6 days a month to enter. The data was also not easy to analyze. To improve the data capture and entry process, to replace the spreadsheet, a QAD Progress program was developed where the production timesheet data could be entered. This was an excellent process improvement that allowed for faster, easier data entry. Since the data was in QAD, browsers, reporting, and dashboards were developed for more effective analysis. But it was still time-consuming, taking 4 days a month for data entry. To justify the operation, the machine operators had been given tablets to enter machine maintenance requests into a Smartsheets forms. So why not do the same thing with QAD? QAD did not offer an app to do this, and the solutions were costly and would have to have been tailored to our needs. Additionally, we wanted to be able to use the solution to capture a variety of data and apply different solutions to the process. We also wanted to have control over the back end, so we could easily adjust and create different options from the captured data. We designed our own app in-house based on the previous data capture screen we had written. The solution was to design our own app made sense as we could control and adjust the process easily. We then approached 32Soft to help with the front-end development of the application. We felt that 32Soft offered similar types of connectivity with their data loaders and liked the idea of going with a local company that we could work directly with and incur less costs and additional expenses. I'm now going to jump to the demo, and we can go through that before coming back to the rest of the presentation. So this is the front-end screen of the Downtime app that appears on the tablets. Log in. So when the operator logs in, they get this screen. They pick a machine. Pick machine 2, I don't know what's on it. And it pulls up the machine, the part, and then they can put in a down code or an up code. So let's just say this machine is running. We'll record the time. They can put in a counter, and they can write a comment if they want to. If they would also done a quality check, they would just check this box, and then they save the record. It's that simple and easy to use. The data we capture from this, before I show you the data, these are the down codes they can enter into the system. as I mentioned, there's like the weekend starts to capture things like to avoid machines being over time, and things like shift change where they just capture quantities, counters. Here's an example of some of the data we capture. This is for yesterday. Machine 2 running. The elapsed time is always calculated based on from the current event based to the previous event. So that's why there's no elapsed time on this event yet. It would take a next event to create one. Some of the uses that we have for it is we have some dashboards. So this is the downtime for yesterday, divided out by machine types, small die casting, intermediate die casting, and IMA, which is injection metal assembly. We have a dashboard for downtime for all machines, downtime by machines, and then some charts. They do this for yesterday, the current week, and even for the current month, with different types of charting. Additionally, they've developed a downtime KPI using metrics. We have some numbers that people can see. But one of the supervisors put together a lot of browsers. We'll use the browse to build a bunch of dashboards. And again, with the metrics, you can adjust your values however you seems necessary or fit for your business. We're using Amazon Fire tablets, probably not the best tablets, but you know, they work. They're portable and they have a fairly strong case that you can put them in and drop them. They don't break. So, and if they do, it's, you know, you're looking at a few $100s, not thousands of dollars like walking around with a Surface Pro. Well, the users are all the setup guys, or people. So each machine in small die casting has one setup person for 5 machines, and that's why they transport a tablet around with them. In some of the other areas like in IDC, which are larger machines, there's only one setup person per machine, and so they have a tablet with them at all times. So they enter the data into the tablet and then move on to the next thing they have to do. They also do a lot of smart sheet applications. The tablet, they can pull up work instructions. They can put out of smart sheets. They can record incidents, like if there's someone cuts their finger, they have an incident reporting. They have maintenance. They can do the same type of thing for downtime, but they can do for maintenance as well. So over to maintenance saying, hey, this machine's down, send someone over. The new app eliminated the manual recording and data entry. Say 4 days of manual entry each month. We captured the data in real time, and we can add additional functionality and data capture over time. Currently, we're using the app for casting operations with plans to expand it to the secondary processes as well. The reporting browsers and dashboards give us a vast amount of information, and management uses them daily, weekly, and monthly for analysis and KPI reporting. I mean, we're well over 150,000 records. The downtime app highlighted several issues and gaps, and we were able to make adjustments to address these. How long was the machine down in a specific status? We need to start calculating elapsed time between events to address this. Why was a machine down for 2.5 days? This led to creating weekend start and weekend end codes to remove that time from skewing the data. We were still recording hourly quality checks on paper, so we implemented a QA checkbox in the application to identify the hourly quality checks had been performed. We added a down code called shift change, where the setup person would enter the machine counters at each shift change to give actual production cycles to compare to scale quantity counts for better analysis of actual production. We have developed a tool room downtime maintenance bolt-on system in the QAD app. With the introduction of the downtime app, we have created an integration to link the two systems together. We are looking at implementing the same thing with machine maintenance and adding to the quality check and testing feedback. We would also like to add some additional enhancements to the current data collection screen in the application to provide current state of the machine. This would avoid operators entering multiple events for the same code. We could improve data entry speed and improve accuracy with a tablet at every machine. Currently, the setup person has a tablet and they transport it between machines. If multiple events occur at the same time, reporting might get delayed. Finally, it just came to my attention yesterday that quality has started using the shift change counters to compare shots to the scale counts to figure out scrap at the machine percentages. We have reviewed the history of how we captured downtime, the next steps that we developed, and finally the new downtime app, and some future enhancements and uses of this app. To conclude, Dynacast and I have had a very good working relationship. Started way back with 32print, and then when we needed a loader, like the one that they provided, they quickly created a price loader that from one of the ones they had before. Going with 32soft to develop this app was a simple choice, and we're very pleased with the outcome. Lastly, their support and service has been excellent, both in design, suggestions, and working with Cristian and others to get immediate support on changes has been easy. Really easy to get things done, both with this app and with the loaders where we've had issues. And I haven't found any problems with working with anyone at 32soft. It's always been a pleasure. Thanks, everyone, and I'll be happy to answer any of your questions during the Q&A session. I would now like to pass it back to 32soft, and thank you very much.
Excellent. Robert, thank you so much. As mentioned, we have Cristian Manga with us as well. Cristian worked with Robert on this project, so before we jump into the Q&A, I'm going to real quick pass over to Cristian for just a moment here.
Hello everyone. As Robert mentioned, the Dynacast folks use Amazon Fire tablets to run this application on the shop floor. They use these particular devices because they are reasonably priced, costing a couple $100 a piece, including the protection case. The application can also be run on Android tablets or any other devices with a web browser. This gives the freedom of choice. You need an Apache Tomcat server to host Dyna Downtime app on the same server where QAD's .NET UI application is hosted. If you run QAD.NET UI, then you already have Apache Tomcat in place. Dyna Downtime app can be hosted on the same server, or if you prefer, another dedicated instance of Tomcat can be added for hosting the Downtime app. Servlets JSP technology was used to build this app, and Progress4GL is used on the backend. This diagram shows deployment and the architecture of Dyna Downtime application. Here you see that the app is hosted on the existing Tomcat server. Java Listener is another 32soft proprietary component required here. This Java Listener component is also used by our data loaders to manage QAD data massively. I want to point out that there is no need to purchase any additional hardware or software to run this kind of applications. We are looking forward to working with Robert to expand the application's functionality when Dynacast is ready. And now I'll pass control over to Denise for the Q&A segment.